Hey everyone, so in this video I'll be showing you this new mouthpiece tool that I invented, which I'm calling the Baffle Grapher, because it actually graphs the baffle of a mouthpiece and gives me a 1-to-1 scale visual of the shape of the baffle profile. Most of the parts are 3D printed, and I'll be going into the whole design process later in this video. And actually I've already made the second version of this tool, which is a lot more accurate actually, but works in a totally different way. But I'll be explaining this one in the next video, so stay tuned for that. So this is the main part of the tool here, which is called a contour gauge, and it uses all these thin pieces of plastic to actually measure the baffle profile. And you can see how these are all individually printed plastic shims. You might have seen contour gauges used in woodworking for copying things like decorative molding shapes and other hard to measure curves. So basically how it works, this section here clamps the mouthpiece against these contour gauge shims, and because they're all the same length, the baffle profile will push these up, and then the top can be read out against this little piece of graph paper here. So here's just one of the 3D printed shims, and it's just 2 layers of printed material, and each of these is about 0.4 millimeters. So all these shims are 0.4 millimeters, except for this very last one, which is a lot thicker. So this is the very last one, and this one's around 2 millimeters. So the only reason why it's thicker is because it's on the end here, and it just lets it not flex so much, and it gives the measurement a bit more stability. So in total, there's 84 thin shims, and then that one thick one at the end. Before measuring an actual mouthpiece, I printed out some random shapes to show you how the contour gauge can follow pretty much any geometry. So first I can just move this part out of the way. Just like that. So this is the first shape, and I'm just going to use these to press into the shims here. So just let these shims fall down as far as they want to go. So you can see how that traces out the shape. Down here is just replicated all the way at the top. Here's the second shape. And the third shape. Now, to give you a demo of how the whole process works, I'll be using this 3D printed mouthpiece that I designed with this really weird baffle shape. It only looks like this to make it easier to see what's happening. It's not necessarily designed to function well as a mouthpiece. Most actual baffle profiles are much more gentle than this. Okay, now for the actual demo of this thing. This part here just loosens, and this flips down and tightens with just a really good friction tighten there, and it really holds it in place. These are called expanding collets, but I'll explain that in just a little bit. This will hold the mouthpiece in place against the shims here. So this expanding collet here is for tenor, and there's one for clarinet, soprano, and alto also, which is kind of overkill, but I just thought I'd include that because I can, I guess. So that goes on here. And then you give this a little bit of a loosen, so this is free to move. Then with the shims out of the way, I basically push the table of the mouthpiece flush against this flat part here, and then tighten it down. And just a little tighten of this screw here will engage that expanding collet, which pushes out these little pieces on the inside and holds the mouthpiece from the inside really tightly. And this is also tightened down, so this whole thing does not move at all. And then here's the cool part. Once this is set up, these gauges will just fall down as far as they can, and you just kind of go over it a few times, just get them all to fall as low as possible, and they will trace out that shape. And then to actually plot the graph, you can just take a pen and trace it along the top part of these shims here. So then to release it, I can either take the whole mouthpiece off, or I can just loosen this screw a little bit here, and then the paper comes right out. So this is the line that it generates, and you can see kind of right here it's a little bit thicker, but that doesn't matter because I'm only measuring from the very bottom of the line. And then I'll take pictures of these and put it in the computer where I'll show you really zoomed in on how accurate this actually is. But you can see following the bottom of the line, it has those two kind of triangular ridges and then that rounded one. If you look back in the video, that's exactly the shape of the baffle. So this is a 1-to-1 scale graph of the baffle, and these markings here are actually in millimeters. So this 30 is exactly 30 millimeters. If you look really close, those faint individual lines are 1 millimeter boxes. So that's kind of the resolution of what this can read out. So you might be wondering how accurate this actually is, and to kind of show you that, I'm going to do 10 different graphs of this, well 10 of the same mouthpiece, 10 in a row, and I'll be taking the mouthpiece off every time, so it's a fresh start, and then I will scan or take pictures of all the graphs and show them really up close in the computer so you can see kind of the variation between 10 measurements of the same piece. So I have a bunch of little cut-out graph paper pieces, and then I'll do a little time-lapse of 10 measurements. So now I'll show you all these graphs in the computer. So zoomed up now, you can really see the variation in all 10 graphs. But keep in mind it's zoomed in quite far, so the movement is actually not that big. If you focus on any one point on the graph, you'll notice that it doesn't really jump up and down more than about half a millimeter. So to remind you of the actual scale perspective of this, the distance between the end of the calipers there is 0.5 millimeters compared with the actual baffle size. So it actually is very accurate. But as you'll see in the next video, the second version of this tool actually is more accurate and more consistent. So when we zoom in on one of the graphs, this red line here is actually where I would take the measurement. And then overlaying the actual baffle profile from the 3D model, you can see that it's actually very close to what I measured. So now I'll show you some more details about how I made this model in Fusion 360. So with this 3D model, I can do a cutaway view to better show you how the expanding collet section works. So hopefully you can see where the bolt would go down the middle, and when it clamps those two pieces together, you can see how it'll expand and hold the mouthpiece really tightly from the inside. And then the cross-section of the baffle. And then zooming in on the expanding collet section, you can see how they rotate around like this so you can change sizes. So to show you what that looks like on the actual thing now, you just take out this screw here, or just loosen this. That comes out, and just pull out this bolt. And then this whole thing is free to move around, and I can just select a different size and line it up with this hole here that goes all the way through, and then it'll be ready for soprano, alto, or clarinet measuring. And like I said before, it is kind of overkill to have all four on the same tool, but I guess it's mildly convenient to have them there. So here's the main part of the tool in the slicer program, which generates the code that gets sent to the 3D printer. And here it is after printing. You can see all the support material still on it. And here's a 3D model of another mouthpiece that I designed, and with a bunch of the design sketches for it. And for this video's mouthpiece, here's the slicer, and then actually printing it. If you're interested to see some other things that I've 3D printed, I've also made this drawing machine, which is like a 3-foot wide spirograph type contraption, which is a follow-up from an older drawing machine that I made that was made out of Legos. Both of these machines were used in the creation of my most recent album, Infinite Medium, which features a lot of these drawings across the 8 music videos. If you want more information about this drawing machine, I explained how it works here. It's the second oldest video on this channel. These two machines work in totally different ways. The Lego drawing machine makes these type of drawings, while the 3D printed machine drawings look like this. So this album is my second ever release, which is a progressive metal solo project with instruments like saxophone, iwi, 8-string guitar, and contralto clarinet. A lot of the background animations are from the two drawing machines, but I also included some 3D fractal animations for some of the music videos. So that's about it. I hope you enjoyed this video, and keep an eye out for the next one, where I talk about the second version of this tool. And please go check out my latest album. The link is in the description and on screen right now.